Okay, thank you.
Welcome, sir. All right, so still on R6. R6 is keeping the IDs of their designated routers. And this, we call them link ID. Okay, link IDs. So how do I even explain the link IDs? Let me try to explain. Okay, so on this link, this is a link. The IP address of this interface here is 10.10.10.1 here. And the IP of this interface is 10.10.10.2. Okay. Now, the ID, the link ID, aside the router ID, we also have the link ID. Okay. So, router ID is there, the link ID. The link ID, the highest IP address will be chosen as the link ID, just the name of the link. That's why Ospf is a link state routing protocol. Link state. So this link, every link has an ID, and the highest IP address will be chosen for that matter. So on, yes, back here, it chose this IP as the ID, the link state ID. All right, what about type 3 LSA? We are still on router 6. Type 3 LSA is simply this. Type 3 LSA. Those are the ones which are advertised by the ABRs alone. All the routers inside router area 10 will never know about any route unless they receive it from the ABR. ABR is the one who inform them of any routes outside. Same way, this ABR is going to advertise to area 0 every information inside area 10. So it's serving as a mediator. So router 6 is saying that every route that I receive from the ABR concerning other networks, other remote networks, I'll keep them in my type 3 LSA, or those routes will be identified as type 3 LSA. So the ABR informing the routers about routes of other networks, we say that LSA is a type 3 LSA. So let's go back to router 6 to see the type 3 LSA. And we have all these routes here. And take note, all of them have been received by router 3. That's the LSA. This router 3 here. That's the LSA. Okay, all of those routes have been received by router 3. That is the LSA, which is doing the advert. So far, we have not seen type 4 LSA and type 5 LSA. Are you taking notice? It ends here, all of them. So let's go back to router 10. This one, we are here, we are coming back here. Show IP Ospf database. And it's showing LSA type 1, router LSA. Type 2, that is the IDs of the designated routers. And type 3. That's all. We are not seeing type 4 LSA. And it's saying this type 3 is receiving them from this 2.2.2.2. And what's 2.2.2.2? This one. This router here, that is the ABR. So every type 3 LSA is received by the ABRs. why haven't we received the types 3, the types 4 and 5? It's because we have not configured redistribution on the ASBR. So we are not seeing external routes. These external routes, we are not seeing them from the EIGRP domain. Are we seeing them? 40.40. And this 192. Let's check router 10 again to see whether we are receiving them. Router 10. Show IP route. We are not receiving the 40s. It's not there. Because we haven't redistributed. Oh, it's so pathetic. I should have kept him in the waiting room. So now let's redistribute to see whether the types 5 and 4 and 5 will come. Okay, so ASBR R4 ASBR. Show run. Let's see what you've done on it so far. We have fully configured IP addresses on the ASBRs. Then we are running EIGRP 50 on one interface and Ospf 4 on another interface. We haven't redistributed. So let's redistribute. Redistribution means you are bringing Ospf inside EIGRP and vice versa. So configure terminal router EIGRP 50. Redistribute Ospf number 4, and the metric we are going to use is this. For the bandwidth, we are using 100 for delay, then 255 for reliability, and 1 for load, and 1500 for MTU. So we enter like this, we exit, and router Ospf 4. Please remember, once you are running Ospf 4 here, it should be 4 here. If you enter 5 or any other number, it's not going to work. So this one too, we are redistributing EIGRP number 50. EIGRP number 50. So once we redistribute this way, we expect the EIGRP routes to be propagated in the Ospf domain. So let's go back to R10 and even R6 to see whether we are receiving routes from the EIGRP domain, which I believe we are. So on R10, let's show the routing table again. And yes, this is even telling me that we are receiving external routes. E2. E2 is not new to us. We all know E2. External type 2, where the metric will be fixed. So this is an external route, and this is also an external route coming from elsewhere. So now that we are receiving external routes, let's go back to the database. Show IP Ospf database, and we have our type 1 LSA here, the router LSAs, type 2, the designated routers, type 3, the route that Ospf ABR is bringing, and now watch, we just received more types. This is called the type 4 LSA. And what is inside the type 4 LSA? And which router is even advertising the type 4 LSA? It is the ABR. And what is it advertising? It's advertising a certain ID. Which ID is this? 4.4.4.4. It must be for this router because it's R4. That is how I assign the router IDs according to the router names. This is router 4. So this is router 4. So I assigned the ID 4.4.4.4 to it. This one. And that is the ABR. That is the ABR. What does it mean? R10 must know its ABR. It must know it so that in case it wants to communicate with an external network, it can do so. So type 4 LSA is given by the ABR informing that router about the ID of the ASBR. Does it make sense? Every router must know the ID of the ASBR. ASBR is the external router that connects to the external network. And who will tell you that information? Is it not the ABR? This one, 2.2.2.2. That's the advertising router. So we are here. We are here, router 10. Router 10 has received an advert from this ABR, 2.2.2.2. And 2.2.2.2 is telling router 10 that, look, we have an ASBR in the network, and its ID is 4.4.4. So you must know, be informed. Be informed. So router 2 has informed router 10 that we have an ASBR. So in case you want to communicate with an external network, you can do so. So type 4 LSA is simply telling the ID of the ASBR. And that telling is done by the ABR. So let's go to R62 to see whether it's now receiving type 4 and 5 LSA. We are coming here, R6. So R6 show IP Ospf database, and that is the type 1, type 2, type 3, and type 4. You see, it's still informing R6 that we have an ASBR, and that is the ID, 4.4.4.4. So if a router doesn't know the ID of an ASBR, it cannot communicate with the external world. And the information was given to R6 by its ABR, this 3.3.3.3. The ABR is the one that gossiped about the network to R6. What about type 5? Let's go down. Type 5 is clearly written there. Now is the ASBR which is talking. ASBR has the ID of 4.4. You see how important it is to give your router's ID. If you don't do it that way, then you see IP addresses here. It will be too cumbersome. It will be too cumbersome. So the best way is to assign IDs to your routers. So we know that this ASBR is 4.4.4.4, and it's advertising all these external routes inside of Ospf. It's telling them, and that will be seen as a type 5 LSA. So R6, yeah, it's seeing the 40 network, it's seeing the another 40.8, now it's seeing the 192, all as type 5 because they are external and they are received by the ASBR. So you see type 5 LSAs are simply the external routes which are sent to routers by the ASBR. Please, these days I'm not going to give any notes. I want to enhance learning in the sense that after you have recorded the video, you have to go back and watch again to prepare your own notes. By the time you are done preparing your notes, you have learned. That is a new strategy I'm adapting because I realize students don't have time, okay, because of work schedule and others are fathers and all that, so they don't learn. I don't blame us, but we have to learn. So record the videos, sit back and prepare your own notes. That will be better.
Ranat.
Yes?
Good afternoon.
Afternoon, Bob.
Please give me access. Let me record. I came late a bit.
All right, no problem. Robert. All right, so you are granted access.
Yes, sir. Thank you.
Welcome. So type 5 is the type of LSA which is received from the ASBR concerning external networks. So if you don't configure redistribution, you will never see a type 4 and a type 5 LSAs because those are to do with the ASBR. That is why initially we didn't see the type 5 and type 4 LSAs. Is there any other question? Yes?
Please, what's the difference between the router ID and the loopback ID?
Say again.
The router ID, what's the difference between the router IDs and then the loopback IDs that you have?
Your voice is low. What's the difference between the router ID and the what?
The loopback.
The loopback.
Yes.
Oh. All right, let me explain. You see, on this router here, we configured a lot of loopback interfaces. Those are not IDs. Aside that one, we have physical IPs. I think this interface is 10.10.10. Let's say 1. This one will also be 10.10.10.5 and 10.10.10.9. Aside all these loopback interfaces. This router here needs a router ID. So either I manually configure it as in router Ospf 2, then router ID 5.5.5.5. If I manually configure it this way, the router will not struggle because it has an ID. But if I fail to configure, then the router still needs an ID. So it will look around its interfaces to see whether it has an active IP address. So all these IP addresses, the highest IP address, the highest active IP address will be chosen as the router ID. In this case, assuming we haven't configured loopback interfaces here, R5 will say my router ID is 10.0.0 and .9 because that is the highest IP addresses of the interfaces. You see, it has chosen a router ID. However, if there are loopback configured on the router, this router will ignore this IP and go for the highest loopback IP address and use it as its router's ID. You understand? Because the loopback interfaces do not go down. So routers prefer using loopback addresses as their router IDs. So the loopback IDs in itself are not router IDs, no. But the situation where you don't manually configure the router ID, that is where the router, in its desperate attempt to get a router ID, will choose a loopback ID address for its router ID. Is that clear?
Yeah, that's clear.
All right. Is there any other question, please? So now we we can distinguish between LSA type 1, type 2, type 3, type 4, type 5. Type 7 will come later. Are we okay with that, please? Nanejan, are we okay with that?
Yeah, I'm fine.
All right, so let's move on. Now let's come to the Ospf area.
Please give me access to recording.
Come again, please. Come again, please.
Please give me access to record.
Who is this, please? Who is talking?
This is Nanejan.
All right, Nanejan, let me. Hopefully Isaac won't say that. Too bad. All right, so now let's talk about the stab area, the totally stab, and all those things. What do we need all those areas? The fact is, we don't need them for Ospf to work. We don't need them for Ospf to work. However, we know that Ospf is meant for very, very large networks. Ospf is meant for extremely large networks. So if care is not taken, routing tables are going to be overwhelmed. Hey, what is this? One minute, please. If care is not taken, routing tables are going to be overwhelmed. This small network, if you enter the routing tables of the routers, you can see a long list. What if the network is actually real, so big? So you don't want routers to be overwhelmed because large list of routing tables can crash your routers, So all these area type, as in stub area, totally stub area, not so stubby area, and totally not so stubby areas are in an attempt to reduce the routing updates, yet ensure connectivity. Okay, we want to reduce routing updates and yet ensure connectivity. So let's hop on this router here, R6. I want us to use our this area here, convert this area to be a stub area. Then we'll see the effect. But before we convert, let's go on R6 and see something. So R6, let's check the routing table. Show IP routes. We have this long list. Just a small lab network and see what we already have. Now, if you want to make this area a stub area, then you are telling the router that, look, all this E network, external network, don't receive them just to reduce the routing table. Okay, now watch, what do we see here? Gateway of last resort is not set on R6. If you enter all the routers, you see the same. The gateway of last resort is not set. We are not bothered because on this routing table, we can connect to any network. Okay, so what's here? Let's try to ping the 192 network to see whether we get connectivity. 192, say 200.1, let's do that. So on R6, ping 192.168.200.1. And there's connectivity. Let me repeat. 100, there is connectivity. It's pinging because we can see the 192 here in the routing table. Now, if you want to convert that area to a stub area, we are telling that area that it shouldn't receive external routes. Yet, we still need connectivity to the external routes. How is that going to happen? If you are going to eliminate this from the routing table and yet ensure connectivity, let's see what the stub area will do. So how do we configure an area as a stub area? It's so simple. It's so simple. You jump on each router, Ospf, let's say it's 2. You see, the reason why I always tell you that I prefer using the same process number is I want to be consistent, so that if I'm coming back on any router to add any configuration, I don't enter a different process number. I know that I've used 10 for all the routers, so I don't enter any new process number. But if care is not taken, you have already configured Ospf 2 on the router, and if you come back, you enter Ospf 3. Okay, that will not work. So I prefer using the same number for consistency. Okay, so router Ospf 2, then area 10, start. That's all. You do that on router 5. You come to router 7. Router Ospf 2. Area 10. Stub. Same thing here. And also remember, the ABR is also part of area 10. So router Ospf 2, area 10, stub. Let's do that to see the effect. So we are going on this router, that, and that to configure the stub networks. They will see the effect. I want you to give attention to the default route specifically. So currently on R6, show IP route, we don't have any default route created. Yet we have all these external routes here. After configuring the stub area, all these external routes will go and a default route will be created. So let me first of all check the Ospf number. Show run. In this configuration, I use different process IDs. That is why all the time I have to go and refer. I don't like doing that. So configure terminal, router Ospf number 2, area 10, start. That's all. Let me save. Then I do same on router 7. Let's show run. You see, all the time I have to check to see my Ospf process. That is not a good thing. It is a waste of time. So configure terminal, router Ospf number 2, area 10, start. Right? Then where do I go again? Yeah, R5 and R3. So R5, double, show run. You see process 5. It's a waste of time. All the time I have to check. Next time if I'm coming back, I still have to check. Okay? So please, yes, be consistent. router Ospf 5, area 10, stub. And on R3 here, the last one, that's the ABR. Enable show run to check the Ospf process. Ospf 9. So configure terminal router Ospf 9, area 10, start. Now let's go back to R6 to check the routing table, whether we will see the external route or whether a default route will be created for us. So R6 here, show IP route. What am I seeing? No? Not expected. This is what I'm seeing. This is what I expect to see. So the routing table has been reduced. We don't see the external area anymore. We have configured this area to be a stub area. We only see the inter-area routes. Okay? If these measures were not there, Ospf routers will crash. And what here? A gateway of last resort has been created, pointing to the ABR. So in essence, it's saying that if there's any route you want to reach, which is not inside your routing table, drop it here. Gateway of last resort, drop it here. You see? So let's see whether we can still reach the 192 network, even though it's not in the routing table. Let's ping it. Do we have connectivity? We are still connecting. So stub area in an attempt to reduce the routing table by eliminating external routes, yet still ensuring connectivity. We have ensured connectivity here, and a default route has been created. That is the stub area. Okay, we have a default route created for us. Any question, please? As I said, all these attempts are to reduce the routing table to ensure efficiency. Otherwise, our routers will crash all the time. What about totally stub area? You see, the routing table is still huge. We can see inter-area route here, plenty of them. If it's a real network, our routers, trust me, they will be overwhelmed. Ospf is meant for extremely large networks. So what do we do to also eliminate the inter-area routes, yet still ensuring connectivity? We can do that by converting the area to a totally stub area. So now we have stub area, which will eliminate external routes, and totally stub area will eliminate both external routes and inter-area routes, just to reduce the routing table. Does it make sense? So totally stub area will eliminate inter-area routes in addition to external routes. And how do we configure totally stub area? It's the same as stub area. The commands here on these routers remain the same. Over here, router Ospf, let's say 2, area 10, stub. Okay, same applies to this router, but when you are configuring the ABR, this is how you do it. router OSPF, let's say 2, and watch, area 10, tab, no summary. That's the only difference. So it will be same with all the routers. And when you're configuring the ABR, you bring area 10 stab, no summary. In that case, you are converting this whole area here to be a totally stabbed area. Totally stabbed. It won't receive any inter-area routes. So we are not going to do much. We are only going to the ABR. To remove the stab, you have to remove it first, otherwise it won't work. Then we configure the stab no summary. So we go to R3. And before you do any configuration, you like to show run. Okay, do show run to see what you have so far. Over here, under the OSPF process, I've converted area 10 as stab. So let's remove it from there. Okay, you remove it first. No area 10 stab. You have removed it. Now the command is area 10 stab, no summary. Enter. You do that just on the ABR. The rest will have the stab. Now let's go back to R6 or R7 to see whether they are receiving external routes. So back on R6, it's initially it's receiving all these external routes. Let's go back. Show IP routes. There we go. The routing table has reduced drastically. This will save your routers processing time. Does it mean we don't have connectivity? We still have. Let's bring the 192 again. It's going through. We have. We can even ping this IP here. This interface. Yeah. This interface will be 10.10.20.2. Let's ping it from R6. So ping 10.10.20.2. Is it not responding? It is. Repeat 200 times. It is responding. But the routing table has been reduced drastically. This will save your routers. It's only receiving the intra-area routes. Is that not beautiful? So we know the difference between stub area and totally stub area. Any question, please? No question? All right. In this case, let's check the database of R6 again. Show IP OSPF database. There we go. It has stopped receiving type 4 and type 5 LSA. You see? It's only receiving the type 1. That is, it's PS within the same area, their ID. Type 2, the designated router. And type 3 is even advertising a default route. Watch. Type 3, instead of it telling router says all the numerous routes, it's saying that anywhere, any route, just give them to me. You see, so database has also shrunk for efficiency. All right, let's move on. Now we are going to talk about not so stubby area. Not so stubby.
Senat.
Yes.
So does it mean we configure stub only in these areas, area 10, and we don't do for 20 and area 0.
No. You can do it on all the areas with the exception of area 0.
Oh, okay.
Okay? You have to understand the meaning of the stub area. You want to reduce the routing updates so that your routers don't crash. So it will be smart to configure stub areas in all areas, even totally stub. Okay? Totally stub in all the areas if you have a very large network, with the exception of area 0.
Okay.
Is that clear?
Yeah.
All right. What about not so stubby area? Not so stubby. So as we established last week, the best OSPF design is to have all other areas around area 0. This is area 0. All other areas must revolve around area 0. And a typical ASBR is a router that has one interface in area 0 and another interface in a foreign network, a network which is not an OSPF network. It can be BGP, it can be RIP, it can even be the internet. That is the job of ABR. One interface in area 0 and another. But what if a critical situation arises where you have to connect a foreign area to another area other than area 0? Is it possible? The answer is yes, it is possible. It's not a good design though, but it's possible. Another network, not another OSPF domain, another network, as in it can be an EIGRP, it can be a RIP, BGP, or internet. I'm not talking about another OSPF area. For another OSPF area, it has to be a virtual link. Okay? I'm not talking about another OSPF. In this case, what do you do? All right, there has to be a connection like this. This area here must be configured as a not so stubby area. Not so stubby area. Before it can allow routes from this network to be propagated inside the OSPF area. Other than that, it will not, because this router here is serving as an ASBR in a way, ASBR, true or false? Because ASBR is the router which will connect an OSPF domain to an external network. However, this interface is not connecting to area 0, so it's already flouting the rules of OSPF. So to make it possible, you have to convert that area, this area here, as a not so stubby area. If it's a not so stubby area, one, it's not going to permit external network, both E-type 2 and E-type 1. It won't permit it. So if you check the routing tables of these routers here, you will never, if this area is a not so stubby area, you won't see any external route. It's behaving like a stub area. You won't see all these routes here, external. You won't see them in the routing table. However, if there's a network here, let's say 1.1.1.1, this network, it will show in their routing tables as OSPF N type 2. This N is telling you that the route here It's an external route, fine, but it's seeing it as a not so stable network. So instead of assigning M type, E type 1 to this 1.1.1.1, it will rather assign N to indicate that this area is a not so stable area. It says that still, I don't receive external route. I still don't receive external route. Even though this 1.1.1 is external, I won't assign E to it. I'll assign N. Okay. Then that 1.1.1 will be advertised inside the Ospf domain. So all these routers will see the 1.1.1.1. But they will assign external to it. Okay, whether E2 or E1. So they will see this 1.1.1 as an external type 5. Okay, the E2 and E1 are external type 5. All these routers in the regular areas, you see, we haven't configured these areas as tab. They are just the regular areas. So they will see this external route as type 5. However, these routers which are inside the not so stable areas are going to see the one network as a type 7, LSA type 7. Yes, it's going to see them as LSA type 7. That's the routers in these areas. So that's the difference. If you have an area, an external network that you still want to connect to Ospf domain, but for some reasons, you can't connect to area 0. Let's imagine a scenario, okay? Let's assume you're a multinational company and we have branches worldwide. And our area 0 is in USA. This area here is in USA, United States of America. And this area is in Ghana. And we have this connection to USA. You know how much it will cost us for a whole connection from Ghana to USA? A lot. It can be through fiber, it can be through satellites. And you know, you are going to pay a lot for this connection. Now, let's say we open another branch in Togo. Or we have a partner in Togo. Let me put it that way. We have a partner in Togo, and the partner is running EIGRP in their network. And they want to connect to us. This is Togo. You see, it will be very expensive for this long distance connectivity to area 0. So the catch is, now let's connect to Ghana, area 10. It has to be possible because it will be cheaper to connect to Ghana. That's how come you have the flexibility of creating a not so stable area to allow all these routes here inside the Ospf domain. Okay, so how do we do the configuration for not so stable area? It's so simple. It's so simple. So we want to convert area 10 to a not so stable area. Yeah, NSSA. We are going to do the configurations on all these routers, simple configurations, just as the stub. Configure terminal, router, Ospf, you bring your process ID, area 10, not so stable area. That's all. You see how simple it is? Come on this router Ospf let's say 2. Area 10, not so stable area. You do that for this, and you do the same for this. Area 10, not so stable area. Area 10, not so stable area. Once you do that, what do you expect to see? Inside this routing table of the routers in the NSA, you are not going to see any external route, yet you have connectivity to those external routes. Now, that area which is connecting to you, the networks that is bringing on board, let's say 7.7.7.7 and other networks, the networks that they are bringing on board, these routers are going to see them as Ospf N, either 2 or N, either 1. You know the difference, type 2 and type 1. Talking about the metrics, okay, whether the metric will be cumulative or whatever it is. But the default is type 2. Then these routers here will now see an LSA type 7. They will, however, not see LSA type 5. They will see. These are the type 5s. Yeah. They will see how that they have connectivity. Now, these routers are going to advertise this type 7 inside the OSPF domain, and all these routers here, because they are not NSSA, they will see the 7.7.7 as a type 5. Because as for them, they are receiving type 5 LSs. So that is what we expect. So let's do it. Let's do it. And to do that, we have to undo the configurations that we have given to the routers. Please, are you there?
Yes.
Are you there, please?
Yes.
Yeah.
All right. So now let's go on R6 and undo the configurations that we did. So show run. Do show run.
Yes, we are here.
All right, thank you. Then we are going to take off this tab area configuration from R6. So router OSPF 2, we say no.
Bernard.
Yes? Speaking, please.
Please, I want to ask a question.
All right.
Does it mean that, as in configuring the totally stub area, when you have a stub area on a router, you cannot configure the not so stubby area on that router?
All right, you can't. You have to take it off. Very good question. So we are taking it off. Yeah, not so stubby. Let's be sure again. Do show run. It's gone. It's not there. So now we can configure. We are still in the OSPF process. So area 10, not so stubby area. That's all. You enter. As easy as ABC. Before I do that, let me add the area. Okay, let me add the foreign area. Yes, I need to add. Otherwise, we won't see the effects. So I'm adding the foreign network. this EIGRP network, let me connect some cables. Okay, before I do that, I have to stop this router and stop that. Make my connection and please, if NG is free to, so go ahead and configure it. Very, very nice. Okay, so this domain, let's assume this point-to-point network is the 80 network, and I'll configure a loopback on this router. Okay, let me quickly do that. On this router here, open, enable, show IP interface, brief. I have this loopback configured on it. I did that yesterday. And E0/02, I have this IP on it. So let me think 80.0.0.10. There we go. So now this interface, I have already configured 80.80.80.10 here, R7. Let me check. Where's R7? Open it. Show IP interface. Where is it? That is it. So the configs are there. Now, I want to run EIGRP on, advertise this area as EIGRP number 100. Yeah. So on this R1, I'm going to advertise this, and I'll advertise the 70. Configure terminal router EIGRP 100. Network. Somebody says I should use all zeros. So that's the lazy way of configuring EIGRP. I say advertise all the interfaces. All right. So that is saved. Then I have to run EIGRP on this E0/1 interface on R7. So R7 config T router EIGRP 100 network 80.0.0.8 and /3 like this. Yes, so I've seen R7 just became neighbors with R1. Now, are the routes coming through? Let's check R3 to see whether they are receiving this route. Show IP route. They are not receiving the 80 and the 70 routes. They are not here. Okay? Because we haven't converted the area into a not so stubby area. They are not receiving. Let's go to R10 here to see whether it's also receiving the 80. Yeah, this one, whether it's receiving this one. After we want to converge the network. So R10, show IP route. R10 is also not receiving the 80s and the 77s. So now let's convert the area to a not so stable area and see what will happen. So on R7, do show run. I want to see what is there. So I have this tab area, I will take it off. No area 10, start. Why? Why did they reject it? No area 10, start. Oh, I'm in the EIGRP process. Exit. Do show run. Okay, so router Ospf 2, no area 10, start. Yes, I've taken it away. So area 10, not so stable area. Save. I've already done it on R6. Let me do it on R5 here. So R5, enable show run to see what I have there. And I have a start area. Let me take it off. Configure terminal. IP Ospf 5. No area 10 start. Take it off. And area 10, not so stable area. So I took off the start area and entered the not so stable area. Do same for R3. Yes, the ABR. R3. Show run. I have this tab no summary there, so I'll take it off. Configure terminal. Router Ospf 3. Please ensure you are entering the correct process ID. So no area 10. I've taken it off. Let's show again. Do show run. Under the OSP, you see that I initially entered the stub area before. See, if you take off the stub no auto summary, the stub area appears. So you still have to take that one to off. So no. Yes, we have taken this off on the ABR. So area 10, not so stable area. Okay, now let's see what happens. I've converted area 10 to become a not so stable area. So let's see whether this route here will be admitted in. First of all, let me check R10 to see whether it's receiving those routes. R10, show IP route. Is it? It's not. Why? Let's troubleshoot. Let me go on R3 or even R6 to see whether it's receiving those routes. So show IP route. R3 is also not receiving the.
I think it's because you didn't redistribute the EIGRP.
Beautiful. Who is that? Who talked? Who is this?
Nanajan.
Beautiful. Nanajan, you've done so well. It nearly escaped me. So we'll go on R. Now, R7 here to redistribute EIGRP and redistribute Ospf. Thank you, Naneja. So R7 exits, show run. All right. So router EIGRP 100 redistribute Ospf number 2 metric of 1, 2, 3, 1, 2, 2, 5, 5, 1, 1,500. This duplex thing. Exit router Ospf 2 redistribute EIGRP 100. Yes, the route should now be propagated all the way to R10 here. Let's check to see whether we'll see the 80 and the 77 from Togo. Show IP routes. And there we go. We are seeing them. But I say it is seeing them as an external route. It's seeing the 80 as an external route. Same applies to the 77, E2. Yes, because this router here is in a regular area. What about the routers which are inside the not so stable area, R6? There we go. See, R6 is not receiving any E2 route, any external route. However, it is seeing the 7 network as N and the 80 as N. Let's go back to the code to see the definition for N. N here, see, N type 1, not so stable area type 1, N type 2, not so stable area type 2. That is what we are seeing right now. Okay? That is what we are seeing.
Not.
Yes?
Quick one, I beg. In this this area, the area 10.
Area 10, yeah.
Yeah. Is there a switch connecting the 3 routers, or is it a router?
This one?
Yeah.
It's a switch. So we created a broadcast multi-access network here.
Okay.
Okay? So it's a switch.
Okay.
All right, we wanted to bring all the pieces together.
Okay.
Unibab?
Yeah, Unibab.
All right. But if you realize, R7 is also in the not so stable area, but they are receiving inter-area routes. Are they not? They are receiving inter-area routes. So if you still want to go down further to make it a totally not so stable area.
Ronald.
Yes?
Please, can I ask a question?
All right, please ask.
I'm a bit confused. What is the purpose of not so stable area?
Okay, all these areas are in an attempt to reduce the routing table. Okay, all of them. Okay. We don't want huge entry in the routing table, yet we want to ensure connectivity. Because if you have a router and it's been overwhelmed with routing update, the router can crash.
Okay.
That is the purpose.
So for this reason, okay, so we are not receiving external routes, yet we are receiving some N1 and N2.
Okay.
So at the end of the N1 and N2 routes, so at the end of the day, it's like we are not receiving one, but we've introduced another one. So
okay,
I understand lost over there.
I understand where you are coming from. You remember that I created a scenario, a very challenging scenario, that this is Ghana, this is USA,
Okay.
and that is Togo. Togo company is our partner. They want to connect to our network. We have a challenge, either to connect them all the way to US, which will be very expensive, or connect it to the closest network, Ghana. Okay, so we are trading off. We are trading off. If you can pay for this, that's okay, because the ideal way is to connect an ABR to area 0. But in this case, we couldn't, so we connected this seeming ASBR to this external network running EIGRP 100. Okay? We want this route here to be propagated inside our network. We need the connectivity. All this, supposing we have some PCs here, we want them to be communicating with this Togo people. Let's say this place here is Canada. You understand? We want connectivity. So if you don't receive this route here, we will not have connectivity. That is why we created a not so stable area. Because if we don't create a not so stable area, there's no way by which we can connect an external network to this network. Ideally, this network must be connected to area 0. And area 0 is far, very expensive. So if you have to connect it to another area other than area 0, then this area here must be a not so stable area. So the routers in this not so stable area here are still not going to receive the external routes. You see, when we open the routing table, we didn't. However, we are seeing these networks, okay? We are seeing them. And even them, we are seeing them as N2 inside these routers, okay?
Yes.
So if these routers propagate the 80 and the 77 networks to other routers, they will see them as E2. They will see the 80 and the 77 network as E2. You understand, Robert?
Okay.
So we are trading off.
All right.
So at this point, these routers here are still seeing the inter-area routes. What if we want to do away with all these inter-area routes here, on these routers here? Let's go on R6. Show IP routes. And we have all these inter-area routes here. The routing table is still big. Even though we are receiving the N2, we are not receiving external, but this is too big. What if you want to clear them away? Then you are going to convert that area into a totally not so stable area. Totally not so stable area is going to clear away the entire area routes, still ensuring connectivity. And how do we do that? So simple. So simple. How do we convert area 10 to become a totally not so stable area? It's simple. The configurations that we have assigned to these routers stay intact, okay? They stay intact, they don't change. Area 10, not so stable area, they don't change. Yeah. Area 10, not so stable area, and area 10, not so stable area. But on the ABR, The config will be router Ospf, let's say 3, area 10, not so stable area, no summary. Just like the totally stable area. It's as simple as ABC. We bring the keyword no summary. So we're not going to do much. We're only going to configure the ABR as this one. We're only going to we will take off the old configuration and bring no summary. So let's do it. R3. Let's first check the configurations which are there. So do show run. Okay, we are taking off this. We want to replace it with NSSA no summary. So router Ospf 9 and no this. Yes, we have taken it off. Let me do show run. There's nothing there. So area 10, not so stable area, no summary. Enter. And we have converted it as a totally, just by that command. So we go on R6, we don't expect to see inter-area routes inside the routing table. We'll reduce the routing table drastically. So check, show IP route, and there we go. It has been reduced. And watch, default gateway has been created. Default route has been created. And watch, the routing table has been reduced. That's the purpose. And we are seeing these external networks as N2, not E2. In this case, all these routers here will now receive an LSA type 7 from this route here. Okay? Let's check the database of R6. Show IP Ospf database. So we have the type 1, type 2, type 3, and watch, there's no type 5 or type 4 because we are not receiving external route from the ABR, but instead, what are we seeing? We are seeing LSA type 7, and these are the routes that we are receiving. These same routes that the internal routers here see as routes type 7, when you move over to another area, which is not an NSSA, it will see these routes here as type 5. Let's go to out there. Show IP Ospf database. Is it the type 5? It's saying the 77 and the 80 as type 5 LSA. Yes, because this router is in a regular area. It's not in an NSSA area. So that is about the area types. There's nothing much about it. Area types is there to reduce the routing updates and still ensure connectivity. In fact, it's a must. If you are actually working on an Ospf network, you'll be overwhelmed. The routers will be overwhelmed with a lot of routing updates. So if you don't put measures in place, you always buy new routers. Any question? Let's give ourselves some, let's 5 minutes breaks, okay? Then we'll come and do virtual link. Are you tired already? Hello?
They're not.
Yes?
No. No.
Yeah. So type 7 only update when we implement NSS no summit, right?
Beautiful. Beautiful. When you convert area 10 or any other area as a not so stable area, what is the purpose? What is the purpose of converting that area to a not so stable area? You want to add an external route to it. Under normal circumstances, this external route should be added to area 0. But because of certain, what is the word? Certain obstacles, you can't. So you have to be forced to connect it to another regular area. You have connectivity because this router here is not an ASBR. An ASBR is a router that has one interface in area 0 and another interface in a foreign network. So to make that possible, then this area here must be a not so stable area. Okay, so it's a way of providing solution. Any question, please? All right, so let's give ourselves some 5 minutes, exactly 5 minutes. So if it's 2:41, I'll come back. Yes. Thanks, initially. All right, hello, welcome back. And please, I remember sending you this document. Do we still have it?
Yes.
All right, if you have it, try your hands on the task. Okay, just configure all these tasks here. That's after you have converted the network. Practice. If you don't practice, it won't work. No magic can work like that. Even if you go and take Obinim sticker, I don't believe it will work. So practice all these things. Spoil the configuration, practice, make mistakes, fix it. That's what will get you there. All right, so now we are coming to tackle the virtual link. Virtual link. We have seen a scenario where we have to connect an outside network to an Ospf domain, which is not area 0, like the one we are seeing here. There's an outside network, a foreign network, and due to certain circumstances beyond our control, instead of connecting to area 0, we have to connect it to area 10. Then we converted this area as a not so stable area. What if we have another Ospf area? This network here is not Ospf, it's AIGRP. It can be BGP. It can be RIP. It can be the internet. What if we have another Ospf area, like the one we are seeing here? Then we create a virtual link. Let's assume this one is area 40. Because this area is not connected to area 0, it won't work. The routes here will not be received by all these routers. It won't work. For it to work, this router here, let me shift it here, okay? So that one interface will run in area 40 and another in area 20. So this one has become an ABR. How do you make it work? You create what is called a virtual link. Something like a channel between these two ABRs. You create a tunnel between this router here and that router. We call it a virtual link. And how do we create a virtual link? So simple. This is R10. So it has a router ID of 10.10.10. This one is R2. It has a router ID of 2.2.2.2. And that is area 20. So on R10, router Ospf 2, area 20, virtual link 2.2.2.2. So on this router, they are referring to 2.2.2 as a virtual link. That's all. You go on R2 and do the same. Router Ospf, let's say 3, area 20, virtual link, I refer to 10. The router ID of 10 is 10.10.10.10. That's all. You have created a virtual ID. And after that, you see that the 50 will be propagated to all the routers. And this router here will also start receiving the routes from all the other networks. Should we do it or we are tired? And for this one, it's a simple configuration. You can do it yourselves. What do you think? All right, let's do it. So let me shift this router here, R10 here. Okay, let's check the configuration on R10 to see whether I've assigned IP on the E0/1. So R10, show IP interface brief. E01 has an IP. Okay, so show run. It doesn't have any other config other than the Ospf for this network in area 20, this one. Just that. So we are going to configure area, we are going to advertise this network inside of R10 in Ospf area 40. So Ospf area 40. That is what we are going to do. So on R10, I'm going to advertise this one in area 40. Configure terminal. Remember, you are using the same ID number. This not Ospf 12. If you use any other process ID, it won't work. So network 50.50.50.0, and it's in area 40. We save. Now I come on this router here, configure Ospf and advertise this network. Remember, I have all these loopback interfaces on R11. I just want to see how the routes are propagated. So show IP interface brief. Configure this loopbacks and this here. So run. Okay, so let me take off this EIGRP network. No router, EIGRP 100. So do show run. I don't have anything there. Okay. So Ospf configuration and network. Let me advertise everywhere. Any network with any subnet mask, area 40. So do right. Now, let's see if I'm receiving routes from all this area. R11. Show IP routes. Nothing. Other than the connected routes, I'm not receiving anything. And let's see if these 5 and the 50 routes are also going out. Let's check R1 to see whether they are receiving the 5 routes. Nothing. They are not receiving anything. Why? Because we haven't. It's violating the rule. Every area must be connected to area 0. So once I have not connected that area to area 0, then I have to create a virtual link. See, you are not long list. You are not receiving the 5 networks. So I come here, create a virtual link, and point it to another ASBR here, another ABR here. Over here, this ABR, create a virtual link and point it to this ABR. So let's do it. Remember, I've earlier on configured their virtual IPs. So on R10, exit, do show run. This is what I have so far in the Ospf domain. So router Ospf 12 area 20. Please, if you are not cool, let the question mark help you. Virtual link 2.2.2.2. And I come here, configure area 20, virtual link 10.10.10.10. So R2 show run. I'm showing run because I want to know the process ID of Ospf here. So configure terminal router Ospf 3. Is it 3? Doris, is it 3? Or you are sleeping? Ospf 3, area 20, virtual link 10.10.10.10. Right. Yes, you see now it's lost connection. Now we have seen that it has regained the connection back. So we expect to see some routes in R11. Let's check. Show IP routes, and this time we are receiving all the routes. Okay, after creating the virtual link, they are all coming, plenty, all of them. That is Ospf. See, we have exhausted Ospf. Yeah, we have exhausted Ospf. You have to, the rest is for you to learn. I wanted us to discuss, do something on routing loops, but it will be too much. It will not be fair. Yeah, it will not be fair. Even though we have just spent 2 hours, but it is fully packed. I have to allow you to go and learn, if only you learn. Roberto.
Yes, so.
If only you will learn.
Oh, we will.
Oh, I know. Hey, for you don't joke.
No, all of us, we don't joke.
I say you, not only you. You as in all the class.
Ah, okay.
Everybody, they don't joke.
Yes.
Teddy, Bismarck, Bani, Lawrence, Natalie, Nanejan, they don't joke.
We do our best to
do your best to do what? All right. Next week, the topic is going to be very interesting. Okay. The topic is going to be very interesting. Route tagging. How you can tag to prevent routing loops. How can you use tagging we will intentionally create routing loops and find a means of using route tagging to prevent the loop. It's to do with route maps and all that. Very, very interesting. So please make a date with us next week and have a very wonderful weekend. Kofi Amankwa, you didn't come to class last week. Kofi Amankwa.
Yeah, I went on the work assignment.
Sorry?
I was on the work assignment.
You went where?
Work.